Right, hello, welcome. In this example, we're going to look at how to find the total resistance in this circuit. The circuit's a little unique. It has a few diagonal resistors in it, and it kind of changes the perspective just a little bit, but in the end, we can always redraw it to make it look like what we're comfortable with. So let's look at our perspective. It gave us the positive terminal here and the negative terminal on the bottom, so that's going to be where our battery is going to sit. They just didn't give us the battery because we can't measure resistance with the battery attached. So from the positive terminal, we'll see that we come down and hit a node right away. So we'll open a parenthesis because we're at the node. We'll evaluate each passage that we can take from that node. We can go down and go through R1 before we hit this other node here. And this node happens to attach to all other nodes across the bottom and ground, which means that that is ground. Right? So we'll say that that's the end of R1's branch. Say R1 is in parallel with, we'll go back up to our node line, and we'll follow the next branch down. That we can go down through R2 and hit the same node, right? That one's also in ground. And so we'll say that's in parallel with R2. And at that point, we can go down a few more. So we can say that's in parallel with whatever else is on the other branches here. We go up here again and we see that that's R3. We have no choice but to go through that to get back down to, yet again, ground, right? That bottom node is all ground. So we'll just say that's in parallel with R3. See, that keeps going on to the next one here as well. Our final branch comes down, it turns a corner, but that's still just the same wire. We had no choice but to do that. And then we go through R4 to get down to the same ground line as R3. That means that R3 is in parallel with R4. And that's all of our circuit. So then all of those can lead back to its original ground location. So that means that is the end of our parallel branch, and they're all actually in parallel with each other. We'll plug those in together. Say that we have 1 over 1 over R1, that's 1,000. They're all in kilo ohms, so we can leave them in kilo ohms. We'll leave it as a 1, plus 1 over the next one in kilo ohms, 2.2, plus 1 over 3.3, plus 1 over 6.8. All in kilo ohms, so that means our answer is also in kilo ohms. We expect it to be smaller than the smallest resistor in the circuit. That's R1 over here. So it should be less than 1,000, and we see that it is less than 1,000. We can say that our RT is equal to 0.525 kilo ohms, or we can reduce that over. We can say get it out of kilo ohms and put it down to ohms since it's so small. 525 ohms. Let us know if you have other questions.